In this video, we'll continue taking a look at some of the review problems for quiz number 1, and these again are questions most popularly missed. So question number 4 has to do with z-scores and difference from the mean. With a height of 65 inches, Alexander was the shortest president of a particular club in the past century. The club presidents of the past century have a mean height of 71.9 inches and a standard deviation of 2.4 inches. A. What is the positive difference between Alexander's height and the mean? So the positive difference would just be the larger of the heights, 71.9, minus, what was his height? 65. So we get 71.9 minus 65 is equal to, what, 6.9 inches. All right, next question. How many standard deviations is that? And that's the difference found in part A. So how many standard deviations is that? Well, he's actually 65 inches, which is below the mean, but they asked us for a positive. So 6.9 inches divided by the standard deviation of 2.4 will tell us how many standard deviations that is. So if we take our 6.9 divided by 2.4, that gives us 2.875. Okay, part C, convert Alexander's height to a z-score. So I wanted to remind you here that a z-score is the height that you're looking at, the x, which would be Alexander's height, minus the mean, which in this case is 71.9, divided by the standard deviation. In this case, I should probably use sigma instead of s, because it looks to me like they have the population of presidents. So let me put the correct value in there. So in the equation editor, there's our sigma. So sigma is the population standard deviation, mu is the population mean. So up here, if we were to take x minus mu, we would have the other way, 65 minus 71.9. So let me put that value for our z-score up here. So let me copy this and then actually put our values in here. X is Alexander, which is 65, minus the mean of all the presidents in the club, which is 71.9, divided by the standard deviation, which is 2.4. And what we will end up with is the same number of standard deviations we did in part B, except it's a negative value because it's below the mean. So part C, his z-score is negative 2.875. That means his height is 2.875 standard deviations below the mean. And then D, if we consider usual heights to be those that convert to z-scores between negative 2 and 2, is Alexander's height usual or unusual? This is our range rule of thumb. He is more than 2 standard deviations below the mean, so his height would be considered unusual in the heights of the presidents. All right, we'll go ahead and do the next question on this video as well. Question number 5 says that the following are duration times in minutes of all missions, let me put this up here, all missions flown by a space shuttle. Use the given data to construct a box plot and identify the 5-number summary. So a 5-number summary starts with the minimum, the first quartile, the median, the third quartile, and then the maximum. So I already know that I have a minimum of 3 and I have a maximum of 11,869. Since we have, you could put all of these in the calculator and the calculator will tell you what they all are. So maybe I'll go ahead and do that. I'm going to pause the video while I go ahead and put these in the calculator. All right, I've got these in the calculator now, in list. And the reason why is because we can go to Stat, Calculate, One Variable Stats. I'm using list 1. And if you scroll down, this gives you what you're used to seeing, the mean, the standard deviation. If you scroll down, it will tell you the 4-number or the 5-number summary. So the minimum would be 3. The median, 10,016.5, that means these are all in order. There's 10 of them, so it's the average between the middle two. The first quartile, 8684, that's the median of the lower half. There's our 8,684 is the median of the lower five numbers. Third quartile is the median of the upper five numbers, which is 11,451. So that's our 5-number summary. And then for the box plot, you would make sure that you had your scale and started maybe at 0, since 3 is the smallest number, up to 12,000. And then make sure your units are marked off accurately from 0 to 12,000. And then you would have a dot at 3, a dot at 11,869, and you would make a box. The first quartile, median, and third quartile, you would make a box with a line in the middle where the median is, and then draw your values out. So we didn't have trouble with that particular part. It was the trouble finding the 5-number summary. All right, I hope that helps review